Welcome to part 3 of building a game with Rust and Bevy. So the last episode here we saw the bee lasers, the enemy and the explosion. In this episode here we are going to see the enemy lasers, the Ferris explosions, and then the enemy movement with the formation and the approach. Okay, so let's get coding. In the previous episode we had the laser A, which was the laser of our little Ferris, of our player. And now we're going to have laser B, which is going to be the laser for the enemy. So let's create this. First, we're going to add the constant here, and we're going to rename this one, actually, player. And then we're going to do the enemy laser, which is our laser B. As part of our resource now, we're going to have two lasers, the laser of the player, so we're going to rename that as well, player laser. And we're going to have another one here, which is going to be enemy. So in the component, we're going to make the laser for both the player and the enemy. And then we're going to have a structure here, which is going to be from player, which we will add to any entity that come from a player. So a laser from a player will be a laser and a from player. And we'll do the same thing here from the enemy. So we're going to say from enemy. Now we're going to stay in main here, and we need to add our setup and make sure that we have our enemy laser. So enemy. And then the last one here, when we have our laser hit enemy, we need to make sure here that it's with laser, but from player. So the way we do that is actually a tuple, and we're going to do a with from player. So that will only take the lasers that come from the player. So here, when we're going to do the laser here on the iteration, we are just going to get the laser for the from player. Now on the player side, we need to update the way that we spawn the laser. So here, what we need to do is, when we're going to spawn here, we want to make sure to insert the from player. And then in our laser movement, we also need, in our query part here, that will be a tuple and with from player. So that will make sure that the query iterator here, when we're asking the first part here, the data part of the query, we get the entities that have the component lasers and from laser. So here we just want to move the player laser here in this file. We're going to press save to make sure everything is okay. And so far so good. We have some warnings over there, but it's okay, just because there's some unused. So now let's go to the enemy. So in our enemy file here, we're going to add our enemy fire. And we're going to add it here, similar to the spawn here, where we're going to fire every 900 milliseconds, for example. So to do that, we just add this. So here we add a system, again, very similar to what we did for the spawn. We're going to do it every 900 milliseconds. Obviously, we can do more complex rules here. And then it's going to be with the system enemy fire, which we're going to define now. So let's define our enemy fire here. So first, we're going to have our mute commands, because we're going to have to spawn new entities, obviously, the new lasers. We're going to have our materials, which is basically our texture. And then we're going to have our enemy query, to know which enemy will fire, and they will all fire at the same time for now. So query, transform, and with enemy. So the query type here takes tuples, but when there's only one, you can just give one. And then the only thing that we care from the enemy is the position, and it doesn't have to be mutable. So now for each enemy, we're going to shoot the laser. For the transformation in the enemy query, just need iter here. Don't need mutable again. And then we're going to extract the XY here from the translation, from the enemy. And then we're going to spawn enemy laser sprite. And here the enemy will spawn all at the same time. And then later we can make it more complex. So similar to the player laser, here we are spawning the sprite bundle. And here's a little trick here. We're going to do a minus scale. So that will flip the enemy laser vertically, going down. And then after, we don't forget here the from enemy. So we have the laser and from enemy, such as we can differentiate both. Press save, everything works. Okay, let's do a cargo run, and we're going to use a cool feature here that was a comment from a previous commenters on a previous video, and that is a feature's Bevy dynamic. Yeah. So when you do cargo run like that, or you can do cargo watch as well, it will compile only the application code and reuse the Bevy engine as a dynamic link. So it's much faster to compile and to render. And then for the production, you obviously compile it normally without the dynamic library. So now if we do that, we get our enemy with the laser spawn. And then if we shoot the enemy, we actually have enemies with one laser spawn. And then obviously here the laser spawn are not moving because we're not making them move. So the only thing that move is the player lasers, which makes total sense. Okay, so now let's do our enemy laser movement. So we're going to close these guys. And we're going to create a new one here, which is going to be FN, enemy laser movement. We're going to add it to our plugin system. It's going to be a normal system. And then in our enemy laser movement, in the argument, we're going to have the command because we want to despawn the laser when it goes down below the window. We need the window size to know when to remove the laser. And then we have our query here, and we don't forget here to have our laser and with from enemy. And here, this is what we're going to add to move. So I'm sparing here the typing. And that will be for each laser of enemy. We iterate. We need to have a mutable here because obviously we need to change the transform. And then we just change the Y value here with the speed and the time step. And then if it's outside of the window, below the window, we have some safe margin here. We're going to despawn the entity. So again, this is why we have the entity here, this one, because that will be created by Bevy. And that is a handle that allows us to get the whole entity with all the components and then remove them. So we're going to press save, and then we're going to run again. And now we have the laser moving. So obviously the laser doesn't hit because we haven't done the collision yet with the Ferris, but it's pretty cool. And now we can have as many lasers, enemies as we want. Okay, starting to be pretty cool. Next one. Okay, so let's do the laser hitting our player here. So we're going to go to main. This is where we have our lasers hitting collision logic. And we're going to rename this one here to be very explicit, player laser hit system. And we'll create another one here, which will be enemy. Now we go down. And we're going to create the system here. And it's going to be very similar here to the other one. So the first one here, we have our command here, our laser query. And then at this time here, we're going to make sure here to query the from enemy. Yeah, so we have the laser from the enemy, and then we have our player query here. So we're going to query the player here, a query single here to get the player because we have only one. And we're going to say if it's okay, and we have the player transform, which is going to be for the collision and the player sprite as well to know the size. So the first thing that we're going to do is compute the size. And again, the size here is all a vector of 2, but the scale is a vector of 3. So here we're making it a vector of 2. And we don't forget here to do the ABS, making everything positive, because otherwise you get some weird side effect. In the player, it doesn't really matter, but in the lasers, it does. So we're going to have that as a best practice now. Then for each enemy laser, so we're going to iterate here through the laser query, and we're going to get the transform and the sprite and the latest entity. Now we do the same thing here for the laser size. We put a size, and we take the laser scale here. Then we're going to compute the collision. And it's very similar to what we had before. So we have the laser size and the laser translation here for the position, and then the player. And now, if we have the collision, we're going to remove the player entity, remove the laser entity. And now the cool thing that we had before is the explosion didn't really depend on the enemy. Yes, we have this explosion to spawn kind of order to spawn an explosion. So we're going to do exactly the same thing here. It doesn't have to even know if it's an enemy or if it's a player. We spawn here, so we don't need to spawn a big sprite bundle and everything. It's very simple. And then we do an insert, and then that is our component, and it just take a position, X, Y. And so obviously here is going to be at the position of the player. And then that's it. We do our magic cargo run with the dynamic. We have the player here, and boom, we explode. And we don't respawn because we haven't done the logic yet about the respawning the player. So before we do the player respawn, we have one bug here in our player laser hit system. And the best way to look at it is actually to make the scale 1, for example. And now if we do our cargo run here, we're going to see that if we go and explode the things with both lasers, we get a crash here. And the reason we get a crash here is that if we go to our player laser hit enemy, we realize that we're actually removing here 1, but we remove for each laser hit. And because we go through the laser, if there's 2 lasers that hit the enemy at the same time, then it will be removed twice. And then we'll get into a negative number. So what we can do here is at the top here, before we start, we're going to create a hash set here. And we make sure that we import the hash set from the standard collection. And that will store the entity every time we remove one, such as we are not going to remove the enemies twice. And then we are going to remove the enemy only if it's not already removed. So here we're going to remove the enemy like this. And also the explosion, we're going to spawn it only once. And then at the end, we don't forget to add it to our enemy blast insert here. We press save, we run our game. And then we're going to try to shoot it with both lasers at the same time. And then it doesn't crash. Okay, so now let's do the player respawn. So first here we can collapse everything, such as we get an idea of what we have. And then the first thing we're going to do here in our constant, we're going to add a constant that will have the player respawn delay. And that will be a F64, which would be a time, and we're going to say 2 seconds. The next one here is we're going to actually create our resources as state. So one state that we're going to use now for our player state is going to be called struct player state. And we'll have a flag to say if the player is on and off, and we'll see later why we have that. It's going to be quite useful. And the second property is going to be a last shot, which is going to be the last time he got shot from the beginning of the game. Then we're going to implement the default for player state. And we'll return on false, because by default it will be on stage. And then the last shot, we'll put it at 0. And then we're going to implement some method here of this object. So struct is how you define your data. And then the way you add method to your object, to your kind of class without inheritance, but to your structure, is using implementation here, player state. And then we're going to have 2 methods. The first one here is shot. So basically when it's going to get shot here, we're going to say that it's not on stage anymore, and that the last shot is going to be the time that is passed here. And then the next one is going to be the spawn, which is just after it gets spawned. And the spawn method here will set obviously to true, because now it's going to be on stage, and then it's going to be here the last shot 0. So now that we have that, we can go to the enemy laser hit player, and we're going to have to add this resource here. So mute player state, and it has to be mutable because we're going to change the state. And then we're going to use a time here to get the time from the beginning of the game. And then in the body, when we remove the player here, just after this, we're going to do a player state shot, and we're going to give the time here. And now we're going to go to our player, and inside our player, we're going to add the player spawn here as a second one. So here is at the beginning, because we want the player to show directly. And then after, we're going to have our player spawn here. And then we are going to check it every half a second. So our player spawn now will check if the player is on, and if it's on, doesn't do anything. And if it's not on, it will check the time and will spawn it when the time is passed. That is a little performance trick here, such as you don't have to check the things 60 times a second, you just check it 2 times a second. So it's order of magnitude less. Also, we don't forget to insert our resource, the resource player state, and we are going to use the default. And now in our player spawn logic, we need a couple of more resources here. So we're going to have the win size, but then after we're going to also have time, which will be a resource time. And then we're going to have a mutable player state, and that will be a resmute player state. Now at the top here, we're going to take the now time, the time from the beginning of the game. And then we're going to extract the last shot here from the player state. And then we put everything in the if statement here. So what we're doing here is we're making sure that the player is not on stage, and also that either the last shot is 0, so that will be the first one, or that the now is after the player respawn delay from the last shot. And at the end here, we don't want to forget to update our state with the player state spawn. Pressing save. So here we need to import this and import that. Cargo run. Oops, we didn't change the scale here. So let's change that. And so we need to go to the main, and we're going to change the scale here to 0.5. Press save. And now we do a cargo run. We get things in better shape. And now we go there. We get exploded. And then we respawn. That's it. And now we can play. So obviously, the enemy is not moving, so we're going to have to make the enemy move now. So to make the enemy move, we go to enemy, and we're going to add a system, and we'll call it enemy movement. And that will be a system function. And first here, we make sure that in our commands enemy here in the spawn, we're also going to insert the speed. And in our enemy system, we're going to require the time, because we'll be using the time here to do the rotation for now. And we'll have the query here of the enemy. So the goal here of our first enemy movement is to have an ellipse here. So the first thing we're going to do is to capture the now, which is the time from since the startup of the game here. And then we're going to do for each enemy, we're going to iterate. And we just need the transformation and the speed. And we need it in query.itermute, and we need the mutable because we are going to change, obviously, the transformation for the position. The first thing we are going to compute here is a maximum distance. Then we are just going to extract the x and the y origin, and then we're going to get the ellipse information. And so the first one here, and for now we just hardcode them, but we're going to still have the variables, such as after is going to be much easier. So it's going to be the offset, the x offset and the y offset from the center of the screen. And then we're going to have the radius, which will going to be the x radius and the y radius, such as we don't have just a circle, we can have an ellipse. So the next one here, which is going to be just for this first movement here, we're going to compute the next angle. So that will make our enemy move. The way we do that is let angle, and it's going to be the speed multiplied by the time step. And then we'll be using the time right now. So all of the thing will turn as the time goes. And then we do a modulo 360. And here we're going to divide it by pi. It's actually a good, it works pretty well like this. We're going to import the pi, and we're going to import the F32 pi. That's good enough. Press save. I forgot that. So now we're going to calculate destination. And to do that, we just do x dst, and we're going to do the x radius multiply by the angle cosinus plus the x offset. And then we're going to do the same thing here for the y. And then we're going to calculate the distance here to make sure that we don't overshoot. Because in fact, our algorithm here takes care of the approach of the enemy to the formation. We're going to call it formation later, to the ellipse. And then once it's in the ellipse, it will also follow the ellipse without overshooting. So that's why we need to calculate the distance. So first here, we're going to have the delta x and the delta y. Then we calculate the distance here. Then we're going to calculate the final distance ratio here. So if it's 0, it's going to be the ratio we have to go towards the direction that the enemy has to move to. And now we can calculate the final xy in relation of how much the enemy can move to. And again, here it's a little bit math here, but is actually avoiding a lot of math, because now you can have the player anywhere in the stage and it will come close to the ellipse and eventually will turn around the ellipse at relatively the same speed here. So there's more math to do if we want to be exactly perfect, but that goes a long way. And the trick here is to make sure that we don't overshoot, because if you overshoot, then your player is going to flicker here all over. So what we do here is the final x will be the xarg minus the dx multiplied by the distance ratio. And here's a trick to make sure that we don't overshoot. And obviously it depends if the dx, if the delta is positive or negative, and then we choose the maximum of the appropriate value here. And then we do exactly the same thing for y. And now we can apply to transformation, and we are just doing that. Okay, we press save. Seems to work pretty well. We do the cargo run. And then, whoops, there's a bug here. It should go around. And here we have this weirdo back and forth. And here, oh, it's because we don't have the right one here. That should be seen. Press save, pause, clear, cargo run. And now we have our ellipse. Okay, math is pretty cool. So that's pretty cool, but it could be better if we make multiple enemies. So let's go back here to the main, and we can have actually multiple enemies. So we can put, for example, 5. And so we see that they all kind of snap together here, because obviously it's the same time for everybody, so they all snap together. So it's actually not very, it's not what we want. What we really want here is a concept of formation. Enemy can have the same formation, and when they join the formation, which will be an ellipse, so they approach and they go to the formation, and then after they will turn around this formation at some distances between each other. So the way to do that is with a formation component and a formation maker resource. So let's see how it works. So first, we're going to make the max enemies to 2. And we're going to have another constant here, which is going to be a max formation members. That will be the number of members of enemies inside the same formation. We're going to see what it means later. And now on the enemy side here, we're going to have a code region here for our formation. And the first thing we're going to have is our component here. And that will be our formation component. And that will be our struct formation. We'll have our start, xy, f32, f32. The convention here is when it's just 2 and it's xy, we're just going to use a tuple here. And the radius, same thing, f32, f32, because we want both to do ellipse. And we're going to have the offset, and same thing, f32, f32. And then the angle here, which will be also f32. And then the group ID here, which we're not really going to use, but it's basically a number, but enemies can share the same formation properties. And here what we can do is we can have the default and the clone, because we'll see later, we'll do the clone. And so now we're going to make the factory, which we are going to call it formation maker, and that will be a resource. So the formation maker here, we'll have a group sequence ID here, which will be for the group number. We'll have the current formation. So the idea here is that multiple enemy will use the same formation. And to make it simple and multi-threaded and everything, we'll just clone it here. It's completely fine. And then we're going to do a current formation members to know when to create the new formation. So now the next step is to implement the formation maker make API. There's going to be a method. It's going to be a mute self because it's going to mute itself. And then the only thing that we need is a win size. which will be a reference of win size to know where to span it. And what it will return here is a formation structure. Okay, so that will be a pretty big method here. And the first thing we're going to do is a pretty neat stuff here. We're going to use a match from Rust, which is actually very powerful. And we're going to match on the tuple, and that will give us something pretty neat. So what we're going to do here is doing a match, and the tuple is going to be, the first one is going to be the self-current formation, which can be none or some of the formation. And then the other one is going to be an operation actually. Self-current formation members greater or equal, and then here we have our constant that we created before, formation members. This allows us here to have the two conditions that we care about. And the first one is if it's the first formation or the previous formation is full. And that is this one. And then the second one is if we are still within the formation. So here we just want to clone. And in this case, the matching condition is just this one. So here at the first here, if we don't have any formation, and we don't really care about the result of this operation here, but this is true, this means that we need to create a new formation. Otherwise, if we have a formation and this operation is false, then we can do this. The very powerful aspect of match here is that we know that from a business logic, we just have two cases. One where we want to create a new formation and one where we want to increment and clone the current formation. And so here, rather to have complex if-else, we can put it in tuples and just have our two cases, and the match and the compiler is going to make sure that our condition is exhaustive. So first here, let's do the second one, which is the easiest one. On the second one here, when we are still within the formation count, we're going to increment the current formation member, and we are just going to clone the current formation here that we get here. So here we get a current formation that is TMPL here, template, formation template, and that is what we return here out of this function. Okay, so let's press save here. So we're going to put the to-do here to not have the error while we code, and then we'll remove it at the end. So the first thing we're going to do here is to calculate the starting point. And the goal of the starting point is to start from the left of the screen or the right of the screen. So here's a way we're going to compute our XY here, where the things spawn. And the first one here is we're going to get a randomizer here, and we're going to have the span here, the height one, and the one on the width. And what we want is to appear on the side, outside of the screen, and within this kind of area here, which is the height divided by 2 with less some margin here. And then after we decide here some little randomize to say on the left or on the right. And then here we have a randomize here to have the minus and the plus range. That would give us the XY of the enemy. And now we're going to compute the offset and the radius. So we're going to use a variable here that we computed on top here, the hash span and the below span. And we're going to compute the offset within this range. And we're going to compute the radius as well. And the radius here, for now, we're just going to say the X radius is going to be between 80 and 150. And the height is always going to be 100. And then after, we're going to calculate our angle. And the angle here is really the angle of where the center of the ellipse is compared to the position here, XY, that we computed over here. So that will give us the first angle here. And this angle here is what we're going to move as the enemy is coming closer to the ellipse, the approach, and then we're going to tick it every time with the event loop. Then next here, we're going to create a formation here. So again, because it's a new formation, we're going to update the formation sequence ID here, such as it's going to be a group ID here that we'll be using. So far, we're not going to use that in the code, but again, this is for future. And then we have our start, our offset, our radius, and our angle. And then finally, at the end, we just set the current formation here to be an option, a sum of this formation here, this clone. So we're going to clone it, such as that would be the template. We set the counter to 1, because that would be the first formation, so the first member of the formation. And then we return the formation we just created. Press save. Now we need to set this up. So we go back down here. So here in the application plugin, we need to obviously insert the resource. And we're going to formation maker default. And then here, we're going to, when we spawn an enemy, we're going to actually need to have our formation maker, because that is what is going to give us the original XY. And it's going to be mutable because obviously it mute the state when we do that. So now we don't need that anymore. We can replace this with that, because now we're asking the new formation here every time we spawn the enemy, and we're grabbing the XY here. And then we do not forget here, again, because the formation is a component of the enemy, so we do not forget to do insert formation. And now we're going to go to the enemy, and that is where things is going to happen. And the first thing that we're going to do here is obviously in the query here, we need the transform, the speed, as well as the mute formation. And then here we need mute formation. And now our X offset and the radius here is not coming from hard-coded. That is going to come from formation offset, and the radius from formation radius. Now when we compute the next angle here, we don't need the time anymore. Actually, we can remove this now. And the things that we need to do here, and we're going to add a little kind of a twist here. If it comes from the left, we'll turn clockwise, and if it comes from the right, we turn counterclockwise. So D here is for the direction. And then the angle here is the formation angle plus the delta for each tick, which will be the direction, which will be always the same for the same formation, multiplied by the speed, by the time step. And here is kind of something that works pretty well. Again, there's probably better math, but that is about the same speed of what you will find when you join the formation. And then everything will stay the same here. So the same logic about the overshoot and everything. And then the last one here, and that is a little trick that makes it very nice, is we are going to start rotating only when the sprite comes pretty close to the formation, to the ellipse. Because again, it comes from the outside, it's going to come close to the ellipse, and then we want to start it, the target, to rotate. And the way you do that here is basically if the distance is about coming close here, so that is what works well. Again, there's probably a better math way, but that works pretty well. Then we update the formation angle. So here, until the enemy is far, the formation angle will never be updated. So it will be always n+1 in a way, but without ticking. But then when you have the enemy on or close to where it's supposed to be, then the formation angle gets updated, and that will start rotating the whole thing. Now we press save. Now we don't need the time anymore. And the formation maker doesn't have a default, which we might have forgotten to put it there. Yes, so here we can add just the default. Press save, everything seems to be good. And then we're going to do our cargo run. And now it comes from the outside. It's pretty cool. That is two of the same formation here. And they look pretty good. So now the second one here is going to be another formation. So here we can see that is another kind of ellipse. And then day one, I lose. Pretty cool. And then if we want to have fun here, we can change the max enemies to 4, such as we are going to have 2 formations in the screen here at the same time. Now we're going to do our cargo run. And we're going to go on the side here to make sure everything's, oh, I got this destroyed. And then that's it. We have our 2 formations here. And so if I kill one, I should have another one somewhere. That's over there. They're all. So it's getting a little bit tricky here. Okay, so that will be it for today. Hopefully you liked it. If you did, feel free to add a like. Subscribe to see more Rust videos about game, web development, and more. Until next one, happy coding.